Assalamualaikum and a very good day. We are from Group K and today we will present to you about the heat transfer in pipes. So here is Group K's member. The first one is Nur Najha binti Adnan. She is the leader and she did the method simulation for ANSYS. Next is Muhammad Nazrin bin Janis. He did the problem and the geometry detail and dimension. The third group members is me, Nur Ashla binti Muhammad Anwar. I did the introduction of the group, the introduction for our topic and the theory of our topic. Lastly is Muhammad Shamin bin Kamaruddin. He did explain the result and lastly relate the result with the above theory. Introduction for heat transfer in pipes. Heat transfer between the fluid and the pipe surrounding is an important aspect of piping system design, and computer program is often useful tool to use to help understand the effect of heat transfer. Heat transfer theory. Pipe heat transfer to or from the surroundings can occur by one or combination of following three known heat transfer processes. The first one is convection, second one is conduction, and lastly is radiation. Convection. This refers to the heat transfer of the heat energy by movement of the fluids. Number two, conduction. This refers to the mechanism whereby the energy exchange occurs between the fluid and the pipe wall, insulation, and soil if the pipe is buried due to direct contact. Lastly, radiation. Radiation heat transfer is the electromagnetic transfer of energy from a hot surface to a colder surface and represent the heat transfer without a physical medium.
Assalamualaikum warahmatullahi wabarakatuh. Today I will present the objective of this project. The first, discussing heat transfer to or from a fluid flowing through a straight circular tube. Second, distinguish between the axial or main flow direction. And the third, to calculate the heat flux between the wall and the fluid. We also have a learning outcome. The first is how to use ANSYS Flame software, how to generate mesh and change mesh setting of the element and structure of pipe geometry, how to set velocity in domain, how to obtain the post-processing contour plots for variation fluid velocity in CFD post-processing, and lastly, how to animate the flow in pipe domain using quick animation option. Dimension and geometries. Before we start our analysis, we have to build our model. The first step is create the circle with 0.2 diameter. Second step is extrude to 1 meter. Third step is create a circle with same the diameter, which is 0.2 meter on ZX plane and extrude it to 0.4 meter. The fourth step is create a revolve. Create a new plane and create a new circle at selection part. Then create another plane based in the last plane create and move the plane to negative 0.2 meter. Change the angle to 90 degree and generate. The fifth step is, this is the result after the revolve. After that, create the new circle with diameter 0.2 meter. After that, extrude the circle to 0.2 meter. The sixth step is, these are the result of the geometry and the geometry is ready to analysis.
Part 4. This part is about explaining the method we use in ANSYS machine. After we build the model, open ANSYS machine. Select mesh and select detail of mesh and choose phasic preference to CFD, and for the solver preference, change to fluid. While we use inflation, when the boundary condition is accurately analyzed by generating final mesh near the wall or near boundary, inflation can also be used to resolve CFD boundary layers, electromagnetic air gaps, and high stress concentration. Why mesh is important? Meshing capabilities can help reduce the time and effort required to obtain accurate results from FEA and CFD simulation. Typically, as the mesh gets smaller and denser, the result becomes more accurate. After that, we use boundary condition. Boundary condition is to define a problem that results in a unique solution. We must specify information on the dependent flow variable at domain boundaries. Defining boundaries condition involve identifying the location of boundaries such as inlets, outlets, and walls. Boundary condition inlet. Boundary condition can be used in ANSYS Fluent to provide a prescribed mass flow rate or mass flux distribution at an inlet. The inlet boundary condition is mass flow inlet. A mass flow inlet is often used when it is more important to match a prescribed mass flow rate than to match the total pressure of the inflow stream. Lastly, boundary condition outlet. The distribution of all flow variables, especially flow velocity, must be specified. This is a conjunction to the inlet boundary condition. This type of boundary condition is common and is usually specified when the outlet velocity is known.
Assalamualaikum warahmatullahi wabarakatuh. Next we go for the result. This is counter image for the pipe static temperature. The maximum value for the pipe static temperature is 3.13 exponential 2, while the minimum value for the pipe static temperature is 2.87 exponential 2. So it shows at the top has higher static temperature, while at the bottom has lower static temperature. The red color shows for the maximum value, while the blue color shows for the... Okay, next we go for the scale residual. From observation, we can conclude the continuity X velocity, Y velocity, Z velocity, energy, K and epsilon is decreases. Next we go to the related result with the theory. From the result at the pipe static temperature, we can see the difference of the temperature, which is the maximum value at the top of the pipe is 3.13 exponential 2, while the minimum value at the bottom of pipe is 2.87 exponential of 2. So that we can relate the result with the theory of heat transfer, which is convection. This is because transfer of heat energy by movement of fluid. So there will be a temperature change in the pipe. Finally, we can get the maximum and minimum value. As well, we know pipe heat transfer can occur by one or a combination of three heat transfer processes.